I'll try to make the introduction brief, but as you know, it's pretty extensive. This project will consist of the usage of geometry in the classroom. Within this project, we will discuss the origin of geometry, how it is used in the classroom, and its importance in the classroom and in everyday life. We believe that geometry is a very important aspect of mathematics. It allows children to identify shapes, lines of symmetry. Geometry is used in every aspect of everyday life, such as in architecture. In elementary schools, geometry is a subject that is of high importance, especially in the lower grades, such as kindergarten. It gives meanings to shapes. Circles now have names, and squares have 4 sides. Things that children need to know in order to achieve a higher learning in math, such as angles, like right angles, obtuse, and things like that. Our perception of the importance of geometry was formed during our classroom experience and during the research portion of this project. To know that the Egyptians have to had exact measurements in order to build their magnificent pyramids leads us to acknowledge the importance of geometry.
Okay, so we just want to give you a little background of geometry. The word geometry originated from 2 Greek words, geo, which means earth, and metros, which means to measure. And around 2900 BC, Egyptians constructed a pyramid that required special shapes of stones and precise measurements for each block to fit exactly. The knowledge of geometry was essential for building pyramids, but there was no evidence that they logically deduced geometric facts from basic principles. So their knowledge of measurement was kind of based on tuition, experiment, and approximation.
Early Greeks had the first knowledge of geometry, beginning with Thales and Mylius.
We won't be able to pronounce some of these
His
words.
contribution was by bringing science to geometry, and he was the first to demonstrate the truth of geometric relationships by showing it followed a logical and orderly fashion from a set of universally accepted statements called axiom and postulates. Pythagoras was the next great contributor to geometry. He was Thales' famous pupil and was considered the first pure mathematician. He established a society called Pythagoreans, and they founded the Pythagorean and I can't even say the word, which was named after Pythagoras.
Okay, one of the greatest of all Greek geometers were Euclid of Alexandria, who was considered the father of modern geometry. His famous work was called Elements, and he compiled together 13 books of mathematical knowledge, and 7 of them was devoted to geometry. Most of his theorems from the book are basically taught in schools today. French philosopher and mathematician René Descartes published the first treatise on analytical geometry, which he combined algebra and geometry.
Carl Friedrich Gauss invented non-Euclidean geometry, which is any geometry different from the Euclidean geometry. Non-Euclidean geometry is a system of definition, assumptions, and proofs that describe such objects as points, lines, and planes. The most recent development in geometry is fractal geometry, which was invented by Benoit Mandelbrot. Fractal geometry deals with objects in a non-integer dimension. So now we're going to discuss the math workshop. This is what we're going to be getting into. We're going to identify lines of symmetry, and this would be for a grade 4.
When you're teaching the students, this would be like one of the topics that you would use to, present your lesson to the students.
So this is, our common course standard would be for, the grades would be 3 to 5, and the students should be able to describe line of symmetry in 2-dimensional shapes. Do you want to go ahead?
Yeah, and this would be, I only took one of the course standards, or we took one of the course standards, which we're going to be doing today. It says to recognize a line of symmetry for two-dimensional figure as a line across such figures, such that the figure can be folded along the line into matching parts. Identify line symmetric figures and draw a line of symmetry. So that's basically what we'll be focusing on today in the activity.
Some of the motivational questions that we thought would be essential questions, which we thought would motivate the students, is to ask them what is symmetry, what objects have lines of symmetry, can you find out if a figure has a line of symmetry. Using the human body as an example, it's a great way to get them started and get them motivated. We also wanted to, did you want to talk about the brain pop now?
No.
We also wanted to,
Did you want to mention this first thing?
yeah, we're also wanted to, as one of the activities, we have this brain pop. I don't know if you guys are familiar with it. In the classroom is great. So can I go ahead and go to the website?
Go there.
Is it gonna work?
How can we get it to?
So we go into the site and it's great because it'll show the kids a video of the subject, and it'll also at the end of the video it'll give them questions and examples, and they can come up to the smartboard and do them
You
themselves.
can cut and paste to the URL area.
Well, we actually weren't going to show the actual video, but we were just wanting to show
But
the
this is
actual
one of the
website.
activities that you
If
can
you,
do.
you know, if you weren't familiar with the website, but we were actually going to show you a whole lesson or, you know, a video on brain pop. So you finished? Okay, so the next step would be what the students will know and be able to do. We would explain what a line of symmetry, or define what a line of symmetry is, and basically it's a line of symmetry is where you could fold the image and have both halves match exactly, and that both sides are mirror images of each other. So basically, a teacher would want to explain that to the students before we actually get into a lesson. They will be able to describe lines of symmetry of a given figure, drawing cutout shapes and find line of symmetry, and identify 2D figures with a line of symmetry.
Okay, so we would first start by, obviously the kids would see, the students would see this slide here, and it says which figure is and isn't symmetrical. So what we can do is you can draw a line, or you can do something like this and ask the students, okay, is this symmetrical? Or you can have them come up and do the lines themselves, and then you sort of assess where they are in regards to their understanding of what's a line of symmetry, what's symmetrical and what's not, before you actually start the lesson, which we're going to go into now.
Does anybody want to come up and just draw a line
Draw a line.
through one of the figures,
Anita?
so we could see what a line of symmetry is? Or if you understand what it is? Yeah.
It's fine. You can do the circle if you want.
I'm bored, it's not me.
All right, well, let me get the picture.
Okay.
There you go.
Okay, so we'll just have a student come up and they would themselves draw a line through one of the figures, and then that's how we would assess to see if they understand what a line of symmetry is. Okay, the workshop activity. So the first activity is what we're going to be doing in class today. It's basically to draw and cut cut and draw symmetry shapes. So basically, we will hand out, as I did,
So you guys are going to
construction.
take your construction paper